Alright, this lesson addresses the modulus function or the absolute value function, and this is an overview of that function, how it looks on a graph, how you can make sense of its definition, and solve some basic problems. Alright, so the first thing we need to remember is that the modulus function measures the distance, or the modulus, the absolute value, measures distance from 0. So a lot of people remember that when you have a negative number inside those bars, those absolute value bars, you get a positive number out. The reason that positive number is coming out is because distance can't be negative. Also, one of the neat things about this function is it's very similar to the quadratic function. So if you remember a parabola, the graph of a quadratic function, pretend this is straight. Ooh, that's really bad. Looks something like this. Okay? What makes a parabola unique is that it has a U shape. It also has a vertex and a line of symmetry. So basically, just as a quick review, if we were to fold one side of our graph over this line, it would end up on top of the other part of our graph. Okay, one of the other things is that you'll notice for the parent function, which we're pretending this is even though it's not drawn accurately, y equals x squared, all the y values are positive because every x going in there, positive or negative, gets squared, and every square number becomes positive. Okay. The difference with absolute value functions, and we'll call this the parent function, okay, because it's the most basic form, y equals the absolute value of x, is that rather than a U, it looks like a V, a symmetrical V. Okay, it too has a vertex right here and a line of symmetry. Okay, so you'll also notice that any input going into x here is within the absolute value bars, which means it's measuring distance. So everything is coming out positive, which is why you'd see the range is zero or greater. Alright, so if we look at another type of graph, so here's that parent function again. One of the other things I wanted to mention is this angle formed right here on both sides measures 45 degrees. Okay, just another piece of information that we'll use later. Okay, so this is, that function we just talked about, ax equals the absolute value of x. Look what happens when I suddenly put x plus some number, in this case 4, within the bars, and then subtract or add a number on the outside. It behaves just like a parabola. Whatever makes this 0 when I substitute it for x is the x coordinate of my vertex. When this whole thing is 0, what I'm left with is negative 2. That means my vertex has moved from 0, 0 to negative 4, negative 2, and every other point has moved left 4 and down 2. So just like a parabola. Alright. So here's the technical definition of the modulus function. So basically, the absolute value of x is equal to x if x is greater than or equal to 0. The absolute value of x is equal to negative x if x is less than 0. And I think this is kind of self-explanatory because if you have a negative number, it's less than 0. So we're going to explore how this is applied in a moment. But first, we're going to look at how the modulus changes the graph of a quadratic. So here we have j of x. Straightforward quadratic graph or equation in factored form with roots at 3 and 1 and a y-intercept at 3, and I'm getting that by multiplying negative 1 and negative 3 together for that y-intercept. I know that the line of symmetry is located in the middle of my two roots, as is my vertex. So I know the x-coordinate of my vertex is 2. If I plug 2 in for every x, I get out -1. Okay, so I'm going to try to sketch this. So this is what my, oops, we're close. This is about what my parabola would look like. Okay, now, as soon as I take this entire function and put it within the absolute value bars, it means that I am not going to get a negative output. That means that this part of my graph that's negative is no longer going to be negative. In fact, all the negatives that happened are now going to be turned into positives. All right, so I know when I put 2 in for x, I got -1. So when I put 2 in for x here, I'm going to get this, -1 also, but within the root bars, okay? Which I know is equal to +1. So now I have a point here, and every point down here is going to be the opposite sign. So it's kind of going to be something like this, like these are going to be all the little points. So it kind of forms almost a little parabola within this. So I'm going to retrace this. So here's the new graph of k of x. Okay, so what you're going to notice, k of x has only positive y values, okay? Whereas j of x had some y values in the negative area.